but did not necessarily abandon. His ideas of matter and form, of the various kinds of causation, of movement, the actualizing of a potentiality, all play an important role in his biological research. But more than once he stresses the importance of appealing to facts in sufficient number before forming general conclusions. I just pause for just a moment there. Francis Bacon made a big to-do about this, and then Darwin, drawing from Francis Bacon's obsession with the fact, Darwin himself made a big to-do out of it and went all around the earth on the Beagle trying to amass some facts on his theory. So Aristotle knew the ultimate basis of induction, evidence. Thus, in the generation of animals, in taking up a difficult problem, Aristotle observes, quote, "There are not enough facts to warrant a conclusion, and more dependence must be placed on facts than on reasoning, which must agree with facts." End quote. In another place he points out that it is easy to distinguish those who argue from facts and those who argue from notions. Yes, just posted the last video in the squabble with Aaron yesterday, and he would be the one who argues from notions, I suppose. Aristotle's collecting of facts in natural history was done in a number of ways. He made countless personal observations of the habits and structures of animals. Some of the facts observed could have been made plain only by the use of the dissecting knife. For example, his description of the eye of the mole, the gallbladder of the pelamid, I don't know what the hell that is, and the stomach in ruminants or cud chewers. In certain cases, there are evidences of the dissection of living animals, i.e. vivisection. Thus, there is reference to the movement of the heart of a tortoise after its removal, and another to the movement of the heart and the sides of a chameleon after dissection. There is also much evidence that Aristotle used, often with critical caution, the observations and reports of others, second-hand evidence. Second-hand evidence has been defined as hearsay by some people. Some of the specific observations that Aristotle made have long stimulated the admiration of naturalists. An example is his distinction of cetacean, cetacean, whatever, whales, dolphins, and porpoises. Right, from fish. He distinguished them from fish. He noted that the former have lungs and blowholes in the embryos tied to the mother by an umbilical cord, and that the young are born alive. Now, I had a problem with one of my philosophy professors in my second to last year of college in literature through philosophy. He said it doesn't matter how we classify things as long as we are logically consistent. Like he said, for example, for ancient scientists or thinkers or for people in the jungle or whatever, it's perfectly reasonable to classify whales as fish because they do swim in the water. The fact they have lungs and hair is not important if your classification system deems it unimportant. And I objected, and I said, actually, the most perfect classification system is our genes, which is a highly mathematical set that just can't be argued against. So our classification system in science should reflect as closely as possible the gene, the facts of our genes. But it certainly doesn't today. Maybe in the future that'll be revised. But at any rate, he was making the case that Aristotle 2,000 plus years ago proved undefensible that whales are fish. He was saying, well, if a culture defines them as fish, then they're fish. Oh, still not fish, buddy. His description of the placental dogfish was not confirmed until the 1800s. Nor was his description of the sexual reproduction of the cuttlefish and the octopus, with the special arm acting as a sexual organ and fitting into the mantle cavity of the female. This list of important observations can be extended easily. Aristotle described carefully the habits of bees, the development of the embryo of the chick, the transformation of the caterpillar to the butterfly, testes of mammals, the habits of electric fish, etc. But Aristotle's zoological works are more than mere descriptions of animal habits, as interesting as that is, that he had all that detailed information on the behavior of bees. Certain fundamental ideas emerge from his descriptive material. Thus we see him supporting, with some elegance, the doctrine of epigenesis, which holds that the embryo develops from undifferentiated material. Again, in the history of animals, Aristotle is constantly concerned with the problem of the sameness and differentness of animals, the problem of classification. And although he nowhere presents a single classificatory system, he makes numerous important statements on classification that allow us to construct a general system. Although we cannot deal with this system in detail, we should note that he recognizes the most general division possible among red-blooded, sanguineous, and non-red-blooded animals, or sanguineous. This division corresponds to the modern distinction between vertebrates and invertebrates, since, as Aristotle had observed, it is the sanguineous animals that have a backbone. Now, when a person nowadays is feeling sanguine, they're feeling a bit heavy or low. And it used to be if you felt sanguine, you had too much blood and they would let blood. His classificatory statements involve the use of the terms eidos, species, eros, species, genus, genus, and analogon. The first corresponds fairly closely to the use of the term species in modern times, and the last two cut across classes, orders, and families, and are used loosely today. Genus, the genus, and the analogon. Now we are going to quote just a bit from Aristotle on the parts of animals. Quote, "We have then first to describe the common functions, common that is to the whole animal kingdom, or to certain large groups, or to the members of a species." In other words, we have to describe the attributes common to all animals, or to assemblages, like the class of birds, of closely allied groups differentiated by gradation, or to groups like man, differentiated into subordinate groups. He says it's not, but there were racists who did differentiate mankind into subordinate groups. But Aristotle saw the case against racism back then, I guess. In the first case, the common attributes may be called analogous, in the second, generic, in the third, specific. Aristotle's general ideas on classification had great vitality until the 18th century and early 19th centuries, long after his authority in physics and philosophy was overthrown. That's 2,200 years his ideas were considered current. His concern with classification seems to have led him to the recognition that nature can be ordered into a hierarchy of living things, a so-called ladder of nature from the simple to the complex. Quoting from Aristotle, "Nature proceeds little by little from things lifeless to animal life in such a way that it is impossible to determine the exact line of demarcation." So he says it's a big gray area, there's no black and white lines, nor on which side thereof an intermediate form should lie. So he says there's no objective means of determining how to classify life. Like I said, genetics is the only real and end of the day answer. And we've got classificatory facts in our current system with Latin terminology and so on that do not reflect and indeed exactly contradict what we know about genes and DNA. So he says it's hard to tell where an intermediate form should lie, this side or that side. Then, next, after lifeless things in the upward scale, come the plant. And of the plants, one will differ from another as to its amount of apparent vitality. Indeed, as we have just remarked, there is observed in plants a continuous scale of ascent towards the animal. So in the sea, there are certain objects concerning which one would be at a loss to determine whether they be animal or vegetable. Let's see, it's not tied down anywhere, yet it isn't active, doesn't have muscle. What the hell? Thus the pinna, P-I-N-N-A, mollusk, is rooted to a particular spot, but it's an animal. And the solen, S-O-L-E-N, or razor shell, cannot survive